Hi, welcome to my presentation, Computing and Astronomy. Um, I am an IT major and created a presentation in how information technology has affected astronomy. The information computational technology in space table of contents. We'll be going through the introductions, a timeline, uses and achievements, future uses, and the references. So information and technology in astronomy have a symbiotic relationship with one another. In order to make observations, predictions, and discoveries, scientists need the math and science to back up their claims. That's where computing comes in. We started out as manual calculators until we automated the process. Some of the key concepts that we'll be going through is communications, information, calculations, evaluations, simulations, and storage. So why paying attention to it or IT? As we continue to grow and evolve as a species, we tend to overlook the significance of certain technologies. It's our innate ability to adapt that once we reach a certain level or plateau, we can't help but to look for what's next. Our curiosity is what feeds our hunger for more knowledge. So just a timeline on the journey for computational growth. Back in the day, computers were people. Um, we had to do all the computing manually. At NASA's JPL, or Jet Propulsion Lab, there was a team of talented individuals known as human computers, hired as such as well. They're comprised of a very intelligent team of women that excelled in mathematics, could perform a myriad of mathematical calculations that were crucial to NASA. These women would then go on to become the first computer programmers at NASA. The longest serving NASA employee, Sue Finley, was originally hired as a human computer. That was until around the 1950s when we started automating the process for calculations. The John von Neumann Maniac computer was devoted to the first stellar evolution codes. These computers were relatively huge, very simple machines by today's standards that would take up roomfuls of information. In the 1950s, the IBM card program electronic calculator, or CPC, was the U.S. space program's first digital computer developed for the Redstone missile and the U.S. Army. The first digital computers, or digital mainframes, were the IBM 650, 704, and 709. They were introduced in the 1950s. Were basically the first computers with hardware for floating point arithmetic. They started out at 18 bits, and for the time were the most complex computational machines to ever exist until the IBM 7090, which was introduced in the 1960s, was basically the first transistorized computer. It was 6 times faster than the 709, started out with 36 bits, and it had very basic programming languages as Fortran, COBOL, sort merge, and map. The ARPANET is basically the internet being born. So ARPA, standing for Advanced Research Projects Agency Network, is basically the DoD's creation in the 1969's first system to incorporate the TCP/IP protocol, which is basically the backbone of today's internet. The IBM 360 system would be the first to connect to the ARPANET in 1971. IBM mainframes were basically NASA's supplier and its only spacecraft computer supplier. Then get to the first supercomputers around the 1970s. The ILIAC 4 supercomputer and the CDC Star 100 Vector. There were supercomputers that were installed in Langley's Research Center and Ames Research Center. The following supercomputers was the Cray lineup, the Cray 1, the Cray 2, and the Cray XMP. The Cray XMP would be NASA's fastest computer from 1983 to 1985. That was until the Cray 2 was installed, and then the Cray XMP replaced that one. Um, this is around the same time that NASA would use a Unix operating system on a supercomputer. Um, then we get to the 90s, computers and rate technology. Around this time, NASA's Advanced Supercomputing was funded around 1980s. 1987, NASA partnership with DARPA, University of Berkeley, to develop RAID, which is a very popular way of backing up your data. The Redundant Array of Inexpensive Disk program, which was basically the precursor for the distributed data storage technology that we have today, as well as the developing AeroNet, which is basically the first WAN, a wide area network connecting supercomputer resources to remote customer sites. Today, NASA contains or houses the most powerful computers that anyone could have. They still take up entire rooms. You have the petascale Pallades, Atkin, Electra, Discover, and Terascale Endeavor supercomputers. They're the most impressive machines that humans have been able to make so far. The systems are based on an SGI and HPE architecture with Intel processors. So what is it all for? So the uses and achievements for computer, basically essential. They kind of have their fingers in literally everything aside from fluid dynamics, aerodynamic simulations, um, simulations in terms of how to get our pilots, astronauts safely back home, assisted many moon missions as well as ISS activities, helped and assisted in creating new technologies, as well as exploring past, present, and futures in planetary bodies when we're dealing with our telescopes, satellites, shuttles, rockets, planes, mooncraft, you name it. Anything that requires math, calculating, computing had some hand in it. And basically, hammering in more hope, that point of essentially computers within everything, in terms of NASA, all the way down to your basic computer figure, astronomer, astrophysicist, all the way up to the supercomputers at the NAS Research Center. Um, the community basically encourages development of high-speed national networks, funding continued basis. There's always going to be a need or requirement for more computational prowess as we continue to evolve and grow as a species, as well as any other capabilities that it has, such as processing, data acquisition, analysis, data reduction, data memory storage or archiving, and informational decoding for telescopes. So what lies ahead? What's in the future for computing in NASA? Basically, right now, there's been a laser communications relay project. Basically, we are trying to encode data onto beams of light. That's what the project or the launch was for, I think, this past 2019, if I'm not mistaken. So basically, this device or technology should allow us to communicate, instead of through radio frequencies, optically through infrared lasers. The data rates should be around 10 to 100 times better, um, and should allow us to have rates up to 1.2 gigabits per second over optical links.
NASA's Laser Communications Relay Demonstration, LCRD, is blasting off to space from Florida to prove we can communicate using lasers. LCRD will relay sample data, like glimpses of planetary surfaces or satellite health down to Earth over infrared lasers.
So it was a quick video, quickly explaining it, and then next on the horizon is quantum computing. Although computer simulations have only gotten more and more complicated, more and more data, there is a revolution going on with the computing side of things. Quantum computing, similar to a classical computer, we'll have bits, but instead of bits, we'll have qubits, which basically are simulated bits of simulated quantum states that react with each other. So there's a probability of 1 and 0 instead of it just being a concrete 1 and 0 like bits usually are in classical computers. The simulations and computing speeds for quantum computers will revolutionize how we calculate information. Although computer simulations have been a big theme, another way that we are processing or progressing is through the viability of quantum computing. It is predicted that quantum computing will significantly help with creating simulated quantum states, which is what we currently haven't. We live in a quantum realm, so to simulate that or have a computational prowess in order to know where that's going, we'll definitely see a lot more discoveries in the future for space programs. And finally, we got to the references, sources, articles, videos. I highly encourage you guys to check it out. Really great stuff. And thank you so much for watching.